Welcome to Module 2.2, where we'll provide an overview of the steps needed to write and deploy smart contracts on Ethereum. If you are interested in blockchain and smart contract development, please stay tuned for our advanced courses that will fully equip you to become an independent blockchain developer. First, let's dig into the languages and structure of smart contracts. Ethereum's primary language for writing smart contracts is Solidity. However, there's also Viper, an alternative that aims for more straightforward and easily auditable code. For those with advanced expertise, there's EUL, an intermediate language designed specifically for the Ethereum virtual machine, EVM. Remember that the Ethereum ecosystem is dynamic, with developers continually exploring and testing new languages. For aspiring smart contract developers, a background in programming languages, particularly JavaScript or Python, can be a valuable foundation. Smart contracts typically operate based on the if this, then that logic, though their applications can span a broad range of variations. One good aspect is that developers don't always need to write these contracts from the ground up. Numerous open-source smart contract libraries are available, offering pre-written contracts that can be adapted to various applications. But it's crucial to review and test any adopted code rigorously to ensure its security and functionality. So, how do you write and deploy a smart contract? Let's use Ethereum as the blockchain to which we'll deploy our smart contract. There are generally 7 stages in the process: setting the stage, tooling up, writing your smart contract, testing, integration, launch, and post-launch monitoring. The first step is to establish a connection with the Ethereum network. This typically involves setting up an Ethereum wallet that can hold Ether, which will be needed to pay for gas. Next, you would install Hardhat, one of the many Ethereum development environments that's beginner-friendly. You would then initiate your new project in Hardhat. Subsequently, you'd draft your smart contract. While it can be written from scratch, more often developers rely on open-source smart contract libraries. Before deploying your smart contract to the main Ethereum network, it's crucial to run your contract on a testnet like Ropsten. This allows you to test and find any vulnerabilities without real-world consequences. Additionally, to let your smart contract interact with external applications, you'd integrate tools like Alchemy, which acts as a bridge between the Ethereum network and your project. Finally, once you're confident in your smart contract, it's deployment time. Using Hardhat, compile your contract, converting your Solidity code into bytecode for the Ethereum virtual machine, EVM, to understand. Then send it to the Ethereum mainnet. After deployment, it's essential to monitor your smart contract's performance, ensuring it functions as expected and watching for any unusual activities. A critical point to remember is that once deployed, smart contracts cannot be altered, a feature necessary to ensure the trustlessness, decentralization, and security of the smart contracts. Given that many smart contracts, whether for a decentralized exchange or as a DIO treasury, usually hold significant digital assets, this immutability becomes vital. This underscores the importance of thorough testing before the official deployment. But what happens if you discover vulnerabilities in your smart contract after deployment? Fortunately, there are strategies to address or upgrade such smart contracts, albeit indirectly. One prevalent method is contract migration. In this approach, you deploy a new version of the smart contract and then transfer the storage and balance from the old contract to this new one. In essence, you are migrating to an improved contract. Another approach to safeguard against vulnerabilities is data separation. Here, instead of a monolithic contract, you create distinct smart contracts, one for business logic and another for storing data. This division should be planned during the smart contract development phase. By doing this, if vulnerabilities arise in the business logic, the data remains secure and separate. Remember, while these methods offer solutions to issues found post-deployment, the gold standard is thorough testing and auditing prior to deployment to minimize risks. Having discussed the crucial steps of deploying smart contracts and addressing their immutability, let's delve into an invaluable tool associated with Ethereum-based smart contracts, Etherscan. Etherscan is a block explorer and analytics platform tailored for the Ethereum network. By verifying your smart contract on Etherscan, you make it transparent, allowing anyone to view your source code and interact with your contract. Beyond its utility for smart contracts, Etherscan offers a wealth of features for general Ethereum users. For instance, one can input any public Ethereum wallet address into Etherscan to retrieve details like current balance, transaction history, associated gas fees, and any smart contracts linked to that address. Additionally, users can search specific transactions and smart contracts on the platform to gain deeper insights into Ethereum network activities. In the next module, we'll have a more detailed overview on the crucial topic of smart contract security.